Alright, so for our final type of problem here in lesson 6.2, combining rational expressions when you actually have quotients instead of products. Now, if you look at that top property right there, if we have nth roots of a and nth roots of b, and it's the same root, in other words, they're both square roots, they're both cube roots, they're both fourth roots, they're both 88th roots. The cool thing is you can take individual roots of tops and bottom, or combine them together to make an nth root of the quotient. Boy, does this look familiar. In fact, it's actually the same as what you see right here in blue. Okay? If I have a square root or any type of nth root of a value times an nth root of another value, I can put them underneath one radical sign and multiply them together. Well, since multiplication and division are inverses of each other, it stands to reason that the same property still holds, and this is an awesome move for us, because guess what that allows us to do? Rather than have us look at example A right here and have to worry about what the square root of 18 divided by, 18x to the fifth is, and do all that fancy stuff we had to do with problem 2, and then repeat the process on the denominator, let alone having to rationalize denominators, which is a handful in itself. I'll save that for your functions class in your next trimester of math. Instead, here's what we're going to do. We're going to take a look at this problem and say, hey, do you notice they're both taking square roots? Because they are both square roots, we can write this underneath one square root, and then ultimately what we can do is just simply reduce that fraction right there. So 18 out of 2 can reduce to the 9. X to the fifth divided by x to the third would be x squared. Remember that property. Imagine taking 1, 2, 3, 4, 5 x's, multiplying those together, and then dividing that by 3x's being multiplied together. Ultimately, what happens here is that the same number divided by the same number makes 1 once, twice, 3 times a 1, and then take a look at what you have left. We have x squared divided by 1, which is another way of just saying x squared, right? You're going to see me float right down here. That's that property right here, right? You reviewed that one probably in some earlier algebra courses. Yes? Yes. So, if I have to take the square root of 9x squared, the nice thing is that 9 is a perfect square, and so is x squared. So getting 3x is pretty much a nice little package for us. It's great. Let's take a look at this cubed root problem. Okay? Once again, looks extremely intimidating with cube roots of numbers that we're not all that comfortable with. But because they are both cube roots, that allows us to take a cube root of the entire quotient. So let's go ahead and reduce the fraction of 162y to the fifth divided by 3y squared, which would take us down to 54y to the third. Now here's where you gotta be on your tippy toes, and that is realize you are not dealing with perfect squares for that list. You're dealing with perfect cubes. So that perfect cube list, right? 1 times 1 times 1, we skip that one, but 2 times 2 times 2 would be 8. 3 times 3 times 3 would be 27. 4 times 4 times 4 would be 64, but do you see why we can stop right there? Because 64 is higher than 54. I think 27 will go into 54. How many times? I think it's 2 times, right? So what I can do with that cube root of 54y to the third is I could write that now as the cube root of 27 times 2, and try not to get tripped up here with this fact this is y to the third. We love the fact this one's y to the third. Why? Why? Good one, Cook. It's because that's a cube root now instead of a square root, right? Because that is a cube root, I don't want to change and split apart and factor that y to the third. Now that allows me to take the cube root of 27, which would be 3. It allows me to take the cube root of y to the third, which would just be y, and then take a look at what we have just left underneath the cube root, which is just that 2 right there. Okay? So, this one here, this one I actually am going to have you pause the video, and I'm going to give you a shot at it. Now what I have here in this box here is just justification for why this works. Remember, why is it okay for us to simplify this as just one big fraction of one big square root? It's okay because we have square roots in the numerator and the denominator. So you can do that first. So how about I get the setup going for you and then we'll pause the video. So because they're both square roots here, I have essentially the same thing as this. 50x to the 6th divided by 2x to the 4th. Alright, let's pause that video, give yourself some time to work, and then see if you can simplify that square root. Okay? Good luck. Alright, so how'd you do? First, did you remember to reduce your fraction? Reduce the fraction. If we got 50 out of 2, wouldn't that just be 25? And then using this property right over here, x to the 6th divided by x to the 4th, wouldn't that be x squared? And then if we take the square root of 25x squared, wouldn't that just be 5x? Kaboom. How'd you do? Good? Good. Alright. So, good luck with that homework. Okay? Couple of key things to note about that homework. Just remember here, going back to this problem here, trust me, you are going to want to multiply all those together. And yes, you are going to end up with a ridiculously large number there. But take a look. Take a look. Go to my webpage. Okay? You go to my webpage, which is probably where all these videos started. See this right over here? The bookmarks? Square root simplifier. What was that number again? It was 1575, wasn't it? So all you have to do, take that number that's right there, type in whatever number you're trying to take that square root of that really large number, 1575, and then take a look. It actually helps you simplify that square root. 15 square roots of 7. Awesome, isn't it? Love it. Remember, no decimals allowed here. I do want to reiterate that. I do not want to see a single decimal on any of these homework problems that you're trying to give me here. Okay? No decimals. Exact answers only, please. All right? Good luck on that homework.